This is Floss Weekly. I'm Doc Searls. Jonathan Bennett and I talked this week with Lorenzo Miniero of Meetecho, which is pronounced other ways as well, but it says meet and echo together, so you can think about what that means. And he's working on Janus and WebRTC, and it's an enormous topic. It's changing rapidly. It has implications for broadcasting, live communications of all kinds. If you care about any of that, this is a great show to listen to, and that is coming up next.
Podcasts you love.
From people you trust.
This is TWiT.
This is Floss Weekly, episode 674, recorded Wednesday, March 30th, 2022. Janus WebRTC. This episode of Floss Weekly is brought to you by Collide. Get endpoint management that puts the user first. Visit collide.com/floss. That's KOLIDE.com/floss to learn more and activate a free 14-day trial today. No credit card required. And by Compiler, an original podcast from Red Hat discussing tech topics big, small, and strange. Listen to Compiler on Apple Podcasts or anywhere you listen to podcasts. Hey there, everybody, everywhere. I am Doc Searls, and this is Floss Weekly, joined this week by Jonathan Bennett himself.
Hey, Doc.
The two of us together are holding down the two central time zones in the U.S. And you're still in Oklahoma. It looks like it.
Yes. I'm rather fond of my my home office here. I spend quite a bit of time out here, and I've set it up for the studio. So this is, until we go traveling again, this is pretty much where you'll see me from.
When you say out, is it another building? Are you somewhere else?
No, it's the back half of it's actually a converted garage. And so it's the back half of the house. So, you have to walk out of the bedrooms, down the hallway and through the sunroom and then into the converted office. So, it is literally the back half of the house.
Yeah, it's like my Santa Barbara office is 2 floors up and a long walk outside in the dirt or the mud, to get there. Here, I just go in the basement. I'm in Bloomington, Indiana, for now. So our guest today, Lorenzo Miniero, who I believe you brought in. Is that correct? Is that you found him for this one?
Yes. So I had a technical problem to solve. Needed to be able to do live streaming of video streams, and we'll get into a bit more of the story of that once we bring Lorenzo on. But I started casting about, looking for, all right, what are the different open source projects out there to be able to do this? And I came up with Meetecho, and Janus is kind of the name of the project itself, I think. Another question for Lorenzo is how those two names interact as far as their corporate structure. And then, so I started working with it, was very impressed. In fact, sent a patch in and was also impressed with the process of getting code folded into their project. And so I thought to myself, well, this would be great. This would be great fodder for Floss Weekly. So I reached out, and Lorenzo was gracious enough to come on and submit himself to our banter and questions.
Well, that's great. Well, I can't wait to get to it. So before we do, I have to let everybody know that this episode of Floss Weekly is brought to you by Collide. That's Collide with a K. Collide is a new take on endpoint management that asks the question, how can we get end users more involved? This is in contrast to old school device management tools like MDM, which lock down your employees' devices and without considering their needs or even attempting to educate them about the security of their laptop. Collide is built by like-minded security practitioners who in the past saw just how much MDM was disrupting their end users, often frustrating them so bad that they would throw up their hands and just switch to using their personal laptops without telling anyone. In that scenario, everyone loses. Collide, on the other hand, is different. Instead of locking down a device, Collide takes a user-focused approach that communicates security recommendations to your employees directly on Slack. After Collide is set up, device security turns from a black and white state into a dynamic conversation. This conversation starts with the end users installing the endpoint agent on their own through a guided process that happens right inside their first Slack message. From there, Collide regularly sends employees recommendations when their device is in an insecure state. This can range from simple problems like the screen lock not being set correctly to hard to solve and nuanced issues like asking people to secure two-factor backup codes sitting in their downloads folder properly. And because it's talking directly to employees, Collide is educating them about the company's policies and how to best keep their devices secure using real, tangible examples, not theoretical scenarios. Collide, cross-platform endpoint management for Linux, Mac, and Windows devices that puts end users first. For Teams, that's Slack. Get endpoint management that puts the user first. Visit collide.com/floss to learn more and activate a free 14-day trial today, no credit card required. Visit kolide.com/floss today. And right now, you can get a goodie bag of Collide swag after signing up for a new trial as their way of saying thank you. Okay, welcome to FLOSS Weekly, and our guest this week is Lorenzo Miniero. He's the chairman and co-founder of Meetcho, or he'll instruct us on the pronunciation of that, along with Janus or Janus, which he's also running. His company provides both consultancy services and communications platform. He has a PhD in computer science from University of Napoli. Federico, that I'm going to massacre that because I'm not sure. Do I guess for two. Anyway, he started working on multimedia conferencing and met the colleagues with whom he co-founded the company as an academic spinoff. He's an active contributor to the Internet Engineering Task Force, the IETF, standardization activities, especially the framework of real-time multimedia apps. He's most known as the author of Janus or Janus, Janus, whatever, a general purpose and open source WebRTC server. He's also a failed and amateur musician. I wouldn't call him failed because I wanted to use his music to introduce this. So he's got good music out there. Passion he still clings to as part of his middle-age crisis. In fact, I really like his music, his bumper music for this show, possibly. So welcome, Lorenzo, to the show. There he is.
Hi, and it's really nice being here. Thank you.
You're in Napoli right now, right? Is that correct?
Yeah, in the south of Italy.
So instruct us on the correct pronunciation of everything I just either mispronounced or polypronounced.
Yeah, you stumbled upon the right pronunciation on everything, basically, because so for the company, there's a bit of a funny story behind there, because initially we wanted the company to sound like Meetcho, which is Italian for awesome, basically. That's the translation for it. So we thought it was a clever name, and we wanted to play a bit with the meat word there because we were doing web conferencing at the time. And unfortunately, back then, we weren't proficient enough with the English language, and so we didn't realize that the extra H in there would actually sound like echo rather than Nico. And so we soon realized that everybody was starting to pronounce the company like Meetecho instead of Meetcho. And so we tried to fight it a bit initially, but then we just gave up. And so now pretty much everybody calls it Meetecho instead, even though we've heard people call it in many different ways, like Meetcho, Meetcho, or a lot of different variations on the team. So, I mean, as long as people know our name, we are happy now, so it doesn't really matter. And for Janus, I mean, it really depends. So I guess it comes from Janus, which is a Roman god, the god of transition. So we pronounce it Giano in Italian, but I really don't know what the right pronunciation is in English instead.
So for people listening and not watching, it's actually spelled with the English words meet and then echo. So those 8 letters are pushed together. So give us the story about Janus and WebRTC and where you stand with that, and so we can focus in on conversation, and Jonathan can take over with really specific questions about it.
Yeah, basically, we had always worked in the real-time multimedia aspect of things, because since I did my master thesis and then my PhD, We were very much working in the field of real-time multimedia applications, also mostly focused on the standardization aspect of things. So I did my master thesis working on a standard protocol that was worked on in the IETF at the time that was called BFCP, and the field was centralized conferencing. That's what the IETF was working on at the time. And basically, after that, we started investing more and more on that. So try and figure out how we could use standard technologies together to do, at the time, mostly web conferencing. So that's how the company was born. So a way to try and sell a product out of our research efforts, basically. And that didn't really work out for several different reasons. The most important being that we were really tiny and trying to fight against very large companies at the time. But we still tried to work and experiment a lot with these kind of standard protocols. And we started also prototyping a bit with ways to get real-time media out of browsers that at the time could only be done using custom plugins. So you needed to have a Flash plugin or a Java applet or something like this in order to get real-time conversational audio and video inside the browser. There wasn't anything else that you could do. And so as soon as WebRTC came out, which again happened as a standardization effort in the WebRTC and the IETF, we were really interested in that. And so we started prototyping stuff right away to try and use WebRTC as part of our own conferencing platform. And we had the advantage that we were already using standard technologies like SIP and RTP and things like this. And so hooking up WebRTC there proved to be relatively straightforward, at least using standard solutions and things like this. And we were at the point where everything was kind of working, but we didn't have much control on the whole stack. So we had expanded on some existing open source tools to do what we needed to do, but all these tools were pretty much vertical on some specific feature, and instead we had many other things in mind about what we wanted to do with WebRTC. And so at the time, I came up with an idea to basically create a component that could be extensible instead. So basically a component that could have a WebRTC core, so something that could talk the WebRTC language, but could then be extended in the backend so that it wouldn't be limited to gatewaying to SIP, for instance, or just do conferencing or just do streaming, but instead try and do as many things as possible. So write an extensible component where you could just plug different plugins and have a different behavior. So do different things with the media that you had. And at the time, this was also the initial period where I was starting to work on my PhD thesis. And at the time, I wanted to work also a bit on how to get real-time broadcasting working as well. So rather than using these standard technologies that are still very much prominent today, like HLS, Dash, and so on, I wanted to investigate if technologies like WebRTC could also be used for broadcasting instead, especially to cut a lot of the latencies involved. So possibly to watch, for instance, a football match in real time rather than see it 30 seconds later. And possibly hear the pub downstairs cheer for a goal that you only see 30 seconds later, which is a true story, by the way. So basically, that's all things that came up pretty much at the same time. And so Janus proved to be a good playground for that as well, because I conceived one of the plugins there, the streaming plugin, was conceived exactly to try and address the broadcasting requirement. We had an SFU plugin to tackle the video conferencing part. We had the SIP plugin because at the time our conferencing platform was based on SIP for the audio part. So we tried to write different plugins that could still be part of the same component, and so could be easier to extend and expand anytime that some new idea came to mind. And this proved to be a successful choice for us, because eventually this kind of flexibility was actually taken advantage of in very creative ways by multiple companies and individuals. So people starting using Janus in ways that we didn't really even think of at the time. So that was really interesting and rewarding for me, because it meant that we made the right choice of choosing a more flexible and general purpose approach rather than just focusing on a single scenario and just do that single scenario very well, basically.
It seems like a great transition for me to fill in the details about what I found so interesting about the Janus project. So I have a bunch of security cameras running over Ethernet, so IP cameras, and they all support RTSP. Where this may be an alphabet soup sort of episode, so put your wizard hats on, if you will. RTSP, the real-time streaming protocol, and then they can supply H.264 as the actual video stream codec. And I was still am using a different piece of open source software called ZoneMinder to be able to, record and stream and watch those different cameras, to be able to do things like keep an eye on my kid as he's playing in the backyard, watch for people traipsing down through the yard, things like that. But the problem with ZoneMinder is it takes that incoming stream and it runs FFmpeg on the back end and does a transition to JPEG for every incoming frame. And that is a lot of processing power it takes. And I got tired of that. And so started looking around with the idea of what can we do to be able to actually do a pass through of this H.264 straight to the browser. And I came up with the Janus project. And it was one of these times where I did a double take. Like, it can't be this easy. I've tried to make this work before with some of the other solutions out there. And it's always been a huge pain to try to do real-time video streaming. It's always been a pain. You have some projects that, they claim to be able to do it, but they haven't touched the code in 5 years and it's bit rotted, just all sorts of things. I wired it up to Janus in a couple of days, I think, and had it working really well. And then I'll go ahead and tell the story. One of the cameras that I had access to has this really weird quirk in its RTSP implementation. Like, I don't think it's technically, I think it breaks the standard technically, but some of the other applications, again, like FFmpeg, VLC, work around it. And so I banged together a quick little patch for Janus and sent it upstream and basically asked the question, hey, would you guys be interested at all in doing this? Or is this, too weird of an approach? And Lorenzo got back to me real quick and said, yeah. And he had, it's funny, he had quite a list of comments on it. And most of them were things like, hey, you used a tab character here. We would prefer for this to be 2 spaces. And I guess to someone that's not in the development world, that stuff might seem like really, really fiddly. But as someone that has done programming, I totally understand caring about a style guide. And then there were also some very boneheaded programming mistakes that I made because slinging C and C++ code is not my day job. So I'm not especially a wizard at it. And so I just wanted to say, before we dive into the rest of this, thank you, Lorenzo, for being gracious about that patch. You were very welcoming, and I appreciated your kind of guiding hand on getting that thing put together and into the code correctly. But yeah, let's talk a little bit.
It's me that should thank you. Actually, I should be thanking contributors in the first place, because nothing forced you to actually contribute something to the project and make it available to all the Janus users. So this is always very much appreciated.
Yeah, there's some projects that you go to push code to, and let's see, I want to be gracious about how I say this, but occasionally developers are like, dude, go read the manual before you send patches in. And I guess that's an okay approach, but I don't know. Your project seems very welcoming of new people and code, and that's pretty cool to see.
Yeah, I mean, that's one of the strong points, I think, of open source, because that's something that I could say, for instance, about the history of Janus in the first place. At the very beginning, we weren't sure whether or not we would want to release it as open source or try to make some money out of it as a proprietary component, for instance. And eventually we chose the open source way, and I always say that it's probably the best choice we ever made, because when you start working on a project and it's just you working on it, there's just so much that you can do. There's just so much that you can test and so much that you can get out of it, basically. Instead, when you release it to the world, then a lot of people can test it and play with it and experiment with it. that means that the whole world can actually start bringing you ideas, contributions, and a lot of enhancements, can start testing it. It makes the project much more fresh, much more robust, and much better in general. And so, for instance, I would never have thought about a contribution like the one that you made, and that would have been something missing in the project that would never have been fixed had you not found the time and the willingness to just go through the project, play with it, and propose a solution, for instance. That's the beauty of open source, I believe, and that's something that always needs to be encouraged.
All right, so I've got to ask, in doing all of this, have you come to the same conclusion that doing video live streaming and trying to work with the different browsers is just a pain?
It's better now, but it was very much a pain, especially at the beginning, mostly because browsers, everything could work one day, and then you go to sleep and you woke up and everything was broken, mostly because a browser update had changed everything. And especially from a standardization perspective, a few years ago, everything was much more in flux as well. So maybe something changed in the standardization, and so it had to change in the implementation as well. And so something that you had working needed to be changed because things basically broke. And now it's much better than before because there are many more interoperability tests. Browsers have managed to basically find ways to better talk to each other, especially from a protocol perspective. So now things are much better, but it's still very much a headache when for instance, you know that something works fine on Chrome and then Safari breaks it entirely. So it's it's still things that keep you up at night sometimes, but it's definitely much better now than it was before.
We have a couple of places in the ZoneMinder code, the stuff that does the integration between ZoneMinder and Janus, and a couple of places. My comment in there is, we shouldn't need this, but the Firefox devs are really stubborn, so this makes it work.
As long as it works, it's all fine, you know.
I suppose that's true. Now, you talk about standards and standardization. Have you guys hit up against the dreaded problem of standard essential patents?
A bit, yeah. Not as personally, but in general, the WebRTC effort has struggled a bit with this, mostly as far as codecs are concerned. So basically, now WebRTC mandates a few codecs. So if you look at the specification and want to implement a WebRTC compliant application, there are a few codecs that you must implement. And so, for instance, you have Opus and G711 for audio, and then you have VP8 and H.264 for video. But for the video part, that actually took a long time to get there, because basically at the beginning, the only mandated codec was VP8 for the simple reason that it's considered royalty-free, basically. And so everybody can, browsers in particular, can implement an encoder and a decoder and not have to worry about royalty fees and so on and so forth. And the same applies to server-side components that do any sort of transcoding on those streams. And for H.264, that was not the same, because of course that's a royalty encumbered codec, and you do need to have licenses if you want to use it, even though the licensing discussions there are a bit weirder, because you have caps under which you don't have to buy licenses. Then it gets complicated real fast. And so the way that they solved this, and there was a huge discussion in the standardization community about which codecs should be in there. And for instance, I was one of the ones that actually antagonized H.264 there, because I really didn't like the licensing approach. Eventually, an agreement was reached where Cisco basically agreed to release an open source version of the codec, for which they would then pay the maximum licensing cap. So basically, as long as you use that specific library, they would pay the costs for H.264 implementations, which is how it ended up in Firefox, in Chrome, in all browsers, and now other server-side components are relying on that as well. It's a bit more complex than that, because formally you have to download the library from a specific place and so on and so forth. But that's basically what allowed H.264 to be one of the mandatory to implement codecs. And I guess it made sense that it ended up there, because H.264 is very much a standard in many legacy components as well. So for instance, you mentioned security cameras. H.264 is pretty much a standard there. Pretty much all security cameras implement H.264. and very few, if maybe none, implement VP8. And so it's much easier if you have the H.264 support. It's much easier to then have a browser access that stream without having to transcode it, which makes a lot of sense. And the same can be said for SIP equipment and infrastructures, which often rely on H.264 as well. So for backward compatibility, having H.264 in the middle was also good news, but it took a while to get there, and it took an effort from both sides to make sure that both codecs could actually end there as well.
So I asked the other guys in the ZoneMinder project what I should ask you about, and the one overwhelming answer I got was, what about AV1 and H.265? And I think ZoneMinder actually has a paying customer that wants H.265 support. So I was told to ask about that.
Yeah, no, it makes a lot of sense. I mean, in general, of course, the H.264 and VP8 are the only mandatory to implement codecs, which means that if you have a WebRTC implementations, you have to at least support those. But WebRTC is based on a negotiation protocol that is SDP that allows you to negotiate also other codecs as well if you support them. And so a few browsers do support additional codecs as well. And the two that you mentioned are among them, at least partially, because, for instance, AV1 for sure is a very new protocol that is being worked on and that has been recently standardized and is completely royalty-free. It's been standardized by the AOM Media Foundation. And basically, it's the first SVC-ready protocol that basically it was conceived with SVC very much in mind, and so it's very much part of the bitstream and the codec itself. And so it's one of the codecs that WebRTC developers are looking forward to a lot because, first of all, it's royalty-free and it's apparently very efficient, especially in lower bitrate situations. And this native SVC functionality means it could open the doors to a lot of interesting things in the future, because right now most applications rely on alternatives way to implement scalable video, typically using simulcast, which is not really scalable video, but it's actually separate streams that you orchestrate somehow. For H.265, it's a bit different, mostly related to the licensing problems that I mentioned about H.264. And typically, I think that the only browser that currently supports H.265 at the moment is Safari. And only when you enable some specific settings in the configuration. So it's not available out of the box. So if you enable that functionality, it means that you can start negotiating H.265 as part of a session, and then you can start using it. But as to my knowledge, no other browser currently supports it. So if making an H.265 stream available today means that only a limited subset of WebRTC users may actually be able to access it. For AV1, it's kind of the same thing, because at the moment, I think only Chrome has partial support for AV1. The SVC functionality is still part of the process, but it's definitely a codec that's most, if not all, browsers will adopt sooner or later, because it's basically seen as the future there. For H.265, I don't see the same thing happening, mostly because it's a royalty-encumbered codec, and if I heard correctly, it's even more complex in terms of licensing than H.264 was, and I really doubt that Cisco will do the same thing of taking over all the costs just to make it available in browsers as they did for H.264. But I mean, both codecs are currently supported in Janus, because Janus just relays video around. So as long as you have endpoints that support those codecs, then you should be able to use them with Janus-based applications already.
I'm kind of surprised that nobody has put together one of those, admittedly ugly, but they work, decoding layers in JavaScript using something like what is it called? The JASM, the JavaScript assembly. There's been some very clever things that's been done with that. Is there a library out there that does that adds like H.265 or AV1 to some of the other browsers?
I mean, this is part of an effort that is actually related to what was some time ago called the new generation of WebRTC. So right now, at the moment, all the encoding and decoding capabilities, so all the WebRTC stack is actually hard-coded within the browser code itself. So it's not exposed at the JavaScript level, where you only work with the raw frames. So you can capture a webcam and a stream, but then you just tell the browser about it, and the browser takes care of encoding, packetizing, and sending it. And at the same time, you never see anything about video or audio coming in and having to decode it, because it's all handed inside the browser, which then makes you available the already decoded streams that you then just have to render in a web page, basically. So one of the efforts that, this led people to wonder if they could have more control over that. So possibly expose some of those layers more at the application level instead, so that if you want, you might want to have more control over the encoding process, the packetization process, and stuff like this. And this is very much still a debate, but that seems to be the direction the standardization is going in. So making the transport level more generic and then leaving all these aspects to you. And in fact, a lot of people have already started experimenting with WebAssembly, for instance, to do what you just meant. So they create their own communication platform, possibly using Quick as a transport rather than WebRTC itself. And then you encode the streams yourself using WebAssembly. You send them over WebSockets, for instance, or over Quick. And then you exchange, and you do the same with incoming streams at the same time, which is the same thing that, for instance, Zoom does in its web version. So they only use WebRTC for the capture part. So they only use the APIs for capturing a webcam and a microphone, but they don't use anything else that WebRTC provides. So they have their own JavaScript-based video encoder and audio encoder, and then they just use something else, which may be WebSockets or data channels, to actually exchange media with the Zoom servers instead. So it's, I guess this summarizes pretty much what you were interested in. So that's the direction where things are going, which is not something that you can do with WebRTC as it is today, though.
All right. Hey, we've got a question from our chat room. We do have a live audience. Jojo Dancer wants to know, what about security and secure stream? What type of encryption can be applied in real time to the stream? And I've looked into this. I think I know the answer, but I will let the expert answer. Can you encrypt a WebRTC stream?
No, WebRTC is encrypted by default, and it's mandatory. So they actually enforced even stricter security considerations there, because I may be a bit more. I maybe go a bit more technical in there, but basically the way that you encrypt the stream is basically using the secure version of RTP, which is the protocol that allows you to exchange media packets. And there are a few different ways by which you can exchange the keys that are used for this SRTP protocol, basically. And one of the most commonly used approach was one that was easy to implement and would have been backward compatible, which was secure descriptions, which was compatible with the legacy VoIP equipment, for instance. But it was also less secure because it meant exchanging this keying information as part of the signaling information. And signaling is accessible to the web servers because they are those that handle the communication process, basically. And so which would have meant that it would have been really easy to intercept the traffic and decode it, for instance. And so in WebRTC, basically you create instead the DTLS channel over which, and so it's a secure peer-to-peer channel over which you exchange this keying information. And then once you do that, you can basically exchange the keys that you will use for SRTP, and nobody can snoop your traffic, basically. And that's I should clarify that this is true for the peer-to-peer kind of approach in WebRTC, because that's how WebRTC was born. So if you have two peers in a WebRTC communication, then these two peers will create a DTLS channel between them, and so it create those as keying exchanges, and that will work. Of course, this changes a bit when you have a server in the middle, like Janus or others, because in that case, you actually kind of break this end-to-end peer-to-peer kind of communication pattern, because you always have a hop-by-hop communication pattern instead. In a conference that goes to a server, you have me talking to the server and the server then talking to you. So you have secure channels over the two legs with the server, but the server does have access to the media itself in that case, because it needs to remove the encryption layer and then encrypt it again to get in the other direction, for instance. Even though there are standardization activities to actually overcome that as well. And one of those is actually the so-called S-frame standardization effort, which basically tries to add an end-to-end encryption layer also in these kind of scenarios where you go to a server, which means that you still do have that hop-by-hop encryption because that's part of the WebRTC specification, but what you exchange are not unencrypted frames. So you don't encrypt the unencrypted frames directly as you would normally do, but you encrypt the payloads additionally as well, so that it's only available and decodable and decryptable by the recipients of the conversation, which means that the server that sits in the middle is only able to decrypt the hop-by-hop layer because that it needs to be like that because that's how WebRTC works, but does not have access to the media itself. And this is something that some have already started using. So we do have support for this functionality in Janus as well, for instance, but it's still a work in process. So the S-frame is still an active working group in the ITF, and they're still ironing out a few of the details about how the protocol is supposed to work, because there are a few challenges in there in terms of how you exchange video, how you make sure that everything works in a backwards compatible way and things like this. So there are a few things that need to be done there, but it's definitely something that is very dear to the WebRTC community in the first place. And so it's something that can be done today as well.
I have some questions coming up. One about WebRTC broadcasting and broadcasting in general, because that's my background, or one of them. But first, I have to let everybody know that this episode of FLOSS Weekly is brought to you by Compiler, an original podcast from Red Hat, discussing tech topics big, small, and strange. Compiler comes to you from the makers of Command Line Heroes and other of our sponsors, and is hosted by Angela Andrews and Brent Simoneau. Technology can be big, bold, bizarre, and complicated. Compiler unravels industry topics, trends, and the things you've always wanted to know about tech through interviews with the people who know it best. On their show, you will hear a chorus of perspectives from the diverse communities behind the code. Compiler brings together a curious team of Red Hatters to tackle big questions in tech, like what is technical debt? What are tech hiring managers actually looking for? And do you have to know how to code to get started in open source? Episode 2 covers what can video games teach us about edge computing? The internet is a patchwork of international agreements and varying infrastructure, but there is something coming to change the ways that we connect. In this episode of Compiler, hosts explore what edge computing could mean for people who enjoy video games and what this form of entertainment could teach us about the technology. Episode 9, how are tech hubs changing? That's another topic. Traditionally, if someone wanted a career in tech, they had to make the move to a tech hub, a city packed with startups and talent. But things are starting to change. The hosts of a Compiler speak to a few of the change makers who are thinking outside the physical and social dimensions we've come to associate with innovation. And speaking personally, I think some of the most common conversations I have with people, especially 2 or 3 generations behind me, is about exactly this topic. So you can learn more about Compiler at red.ht/twit. New episodes are out now. Go and download them at any time, and be sure to check back for new shows. Listen to Compiler on Apple Podcasts or anywhere you listen to podcasts. We'll also include a link on this episode's show page. Thanks to Compiler for their support. So back to the show, I wanted to ask about WebRTC and broadcasting, and both specifically about how you're doing it, and in general, what's happening to the field, because broadcasting used to be something that you had to have a big transmitter. It had limited range. My son, who's now 26, when he was 15, asked me, what's the point of range and coverage? Because he was already net native at that point. He didn't understand what radio and television were about. We've had questions in the back channel about OTT, which is over the top, and there was no over back years ago, and now the over, it seems to me, is what you're working in, right? So give us the general take on what's going on there.
Yeah, I mean, broadcasting in general has of course been a very interesting topic recently at different levels, because there are different technologies that can help there. And the most common ones are, of course, solutions like HLS or Dash or similar solutions that are the ones that provide the streaming technologies as we know them today. So when you use YouTube Live or Twitch or any kind of similar platform, that's the technology that you are using, basically. So, and these technologies work fine. I mean, they have a strong literature behind them in terms of the technologies and the standardization and so on and so forth. But they've always suffered a bit from higher latencies, which isn't problematic in some cases, but can be in others, because especially when latency and smaller delays are desirable, that those can be problematic. And it can be in sporting events, or it can be because you have betting involved, or it may be because you are doing a quiz application that involves a ton of people. In those scenarios, you may want to have as low a latency as possible, so sub-second at the very least, so something that is much closer to what is happening right now rather than what has happened 30 seconds ago, let's say. And that's why, I mean, there is some activity going on at different levels in different standardization organizations as well. Because I mean, one of the solutions can indeed be WebRTC, because WebRTC was conceived for conversational video in the first place. So originally it was born to allow you to have video chats in a browser, but it has been used and abused to do much more than that. So now you see a lot of companies that are using it for webinars or even for broadcasting scenarios. So there are companies that are starting to use this for that. And a few years ago, there was a bit of opposition from the traditional broadcasting industries, mostly because of limitations they saw in the WebRTC specifications in the first place. So, for instance, they mentioned that it couldn't be secure enough, so you couldn't implement, for instance, DRM functionality, or the codecs were not high quality enough, or they weren't reliable enough, or these sort of things. And I mean, all of these were proven wrong time and time again while WebRTC progressed and gathered a lot of functionality. And for instance, AV1 that Jonathan mentioned before could play a strong role here, because since it's an SVC compliant codec, it actually provides a very high quality and the ability also to scale the quality of a stream dynamically within a session. And the same can be said for audio, where Opus provides a very high quality. And in general, WebRTC provides, as part of its specification, a lot of interesting tools and functionality that can help at different levels. That said, WebRTC is not the only option there, because, for instance, last week in Vienna during the ITF meeting, there was a meeting where they were discussing the possibility of sending media packets over QUIC instead. So that's something else that may be an option in the future. So there are different technologies that may help at different layers and at different levels to try and cut down those latency times. I mean, Dash itself is trying to work on a WebRTC version of their own protocol. Of course, since WebRTC is the technology that I'm most familiar with, that's the technology that I investigated the most for the purpose. And so, for instance, I mentioned how broadcasting was indeed the main topic of my PhD a few years ago. So that's what I try to work on. So try to come up with a potential architecture to do an end-to-end kind of broadcasting architecture that could use WebRTC end-to-end. So WebRTC ingestion, WebRTC distribution, so that you could see something that was being captured very close to when it was captured. And so all taking into account the fact that you may need to have a very large audience involved, because, for instance, the sporting event is an event that can be consumed by thousands, hundreds of thousands, or even millions of people. So there are different challenges that need to be addressed to be able to do that via WebRTC, where existing broadcasting technologies have a longer history in there thanks to their usage of CDNs and stuff like this. So there are interesting things that can be done in that space, and I've played a bit with those as well in a few presentations. And the way that we have thought about it is to basically leverage some sort of a tree-based distribution, where you have ingestion that can or cannot be WebRTC based. Then you have a tree-based topology that does not need to rely on WebRTC, but can just work with plain RTP packets, meaning that you can then leverage some other technologies that may be helpful that do not need to be aware of WebRTC at all, and can actually also be just at the network level, like SDNs or multicast or these sort of things. And thanks to this tree-based distribution, the only important thing is that at the edge, you do need to have some nodes that do speak WebRTC to allow then the subscribers to receive the stream that was encoded in the first place. And there are some activities that are also taking place in the standardization activity in the first place, because, for instance, ingestion is a key component in that part, because most of the broadcasting tools that we may be familiar with, like OBS, for instance, is a common example. They do not implement WebRTC, so they typically implement protocols like RTMP to feed a media stream to a broadcasting server. And since they do not talk WebRTC, it's that means it's more problematic to implement an actual WebRTC end-to-end kind of broadcast, which is why the IETF is working on a new protocol that is called WIP to facilitate that aspect. So to focus specifically on the ingestion part and then worry about the distribution later. And this is something that is actually being standardized right now, and I'm very active in that part. And so that's definitely going to be an interesting effort to follow, especially if you're interested in broadcasting in general.
It's humorous that you went into that, because in the back channel we were just talking about, we need to ask him about OBS integration next. So I have this scenario in my mind that, let's say we're running a conference and we want to be able to live stream the whole thing on the internet somewhere, but we really don't want to use one of the existing players for one reason or another. So, no Facebook live streaming, no YouTube live streaming. We're not putting it on Twitch. We actually want to run it out of our own server. We're going to use Janus. But we want to be able to use OBS at the actual location to be able to do fancy things like fade in, fade out, multi-camera, put things over the top. What's the process right now to feed I guess it would be an RTSP stream from OBS up to a server with Janus on it and then out to everybody? Is that pretty simple to do, or is there a lot of legwork that we would have to do to make this work on our imaginary scenario here?
No, I mean, there is a bit of work that needs to be done, mostly because out of the box, OBS only talks the protocols that it does have to care about right now. So any kind of de facto standards in the broadcasting industry, even though, I mean, I've played a lot with OBS for different reasons, and especially I've played a lot with a protocol a technology that is quite common in the broadcasting industry, that is NDI, which stands for Network Device Interface. And so, especially when you are working with OBS and other similar tools, an easy way to get media in and out of OBS is indeed using a technology like NDI. And so in that sense, it means that an easy way, a relatively easy way to get this, what you meant, working is actually more focusing on how can I do WebRTC to NDI and how can I do NDI to WebRTC, and then OBS fits in the picture automatically after that. And that's something that I've been working on at different stages, because initially I focused much more on the WebRTC to NDI kind of functionality, mostly because I wanted to figure out how broadcasters could actually take WebRTC conversations and put them into OBS, and then OBS could do with those whatever it wanted to do, even just publish it to YouTube Live if they wanted. So, and in that sense, that took a bit of an effort, because apparently there aren't many solutions that do that today. And so what I ended up doing was write a new custom plugin in Janus that could basically receive a stream via WebRTC and then decode the audio and video stream, and then turn it into an NDI stream that a local OBS instance could consume. And that actually ended up working quite well. So there is a bit of work that needs to be done in order to make it fit into an existing conversation that is happening online, for instance, but that definitely does work. And so that would cover the first part of your process, for instance. So how do I take an RTSP camera and put it into OBS, for instance, unless OBS supports RTSP out of the box, for instance. RTSP, sorry, out of the box. And then the second part becomes, how can I take the media that OBS is producing and broadcast it via WebRTC rather than YouTube Live or Facebook or anything like this? And this is again another area where NDI could help, because this is part of the experimentation that I did when working with WIP, for instance. Because in that sense, if I can tell OBS to generate an NDI stream out of this stream that I'm producing, and there are plugins that allow you to do that, then this means that I only need a component that can consume this NDI stream and turn it into a WebRTC stream that I can then broadcast. And that's indeed one of the areas where one of my WIP implementations can help, because I did prototype both a client and server side of this WIP protocol that I was discussing that takes care of WebRTC ingestion. And this client-side part I implemented using GStreamer, that is a very flexible library that allows you that has a modular nature as well, and is very flexible in how you can capture and encode media. And so basically I configured the WIP client to consume an NDI stream produced by OBS via NDI. And then WIP itself is conceived to act as a WebRTC producer, because it takes care of WebRTC ingestion, which means that once I got that, it was easy for me to just take that NDI stream, encode it via WebRTC, and send it to Janus so that I could distribute it using the full power of Janus and other things. Yeah, in fact, what you see in that picture over there is a presentation that I made where I actually covered all of these aspects. So especially the broadcasting part, and the demo that I made at the end to show how easy it was to produce a stream in OBS, feed it via NDI out to a WIP client, and then turn it into a WebRTC broadcast out of there. So, I spoke a lot about this, so you can figure out that it's not immediately easy to work with, but it's definitely doable. And hopefully in the future, it will be even easier to do, because, for instance, OBS has now officially started working on a native WebRTC integration for the broadcasting part, because they are, of course, interested in WIP as well, which means that at least the OBS to WebRTC server part should be much easier in the future than it is right now.
So it's been whispered into my ear that we ought to talk about this being used at FOSDEM 22.
Yeah, that's the presentation that I made at FOSDEM 22, and the NDI integration that I mentioned was actually used in production to record another conference that is called ComCon. That is another popular, the most popular conference in Europe for what concerns real-time communication, both VoIP and WebRTC. So I'm actually friends with the founder of ComCon, and basically we work together into using this NDI plugin to actually record all the presentations that were made at that conference. And in fact, they had a producer that was working with traditional broadcasting equipment. So I don't know if he was using OBS or not. I think he was using vMix, which is another popular tool in that context. But it still relied on having access to NDI streams to do the actual producing of the recordings. And so what happened was that the founder of ComCon, who is Dan Jenkins, implemented all the conferencing applications, the conferencing framework that allowed people to basically record their conversation, publish their screen, and so on and so forth. And all this was automatically put in via the NDI plugin in Janus and made available to the vMix backend, so that they could then automatically capture all the separate audio and video streams in the conversation and arranged for whatever the recording needed them to be arranged for. So that was actually quite useful and successful also, because it proved that it could actually work in the real world as well, and not just, let's say, in a lab as I was experimenting with it.
So I want to give you a chance to talk about Meetcho, however we're going to pronounce it, because that is your day job, right? And you're putting a lot of this to work, and I'd like people to know that you know what you're doing with that. It sounds really interesting as well. So do you want to fill us in a bit more on that?
Yeah, I mean the company is we founded the company about 13 years ago, so we've been around quite a long time, but we are still quite a small company because it's about 6 of us in the office. So we never grew that much, and we don't plan to grow that much either. And since at the very beginning we wanted to do web conferencing and try to sell a product, but eventually we pivoted instead to provide some sort of business-to-business kind of functionality instead. So right now we are very much focused on consulting and support services instead. So companies that are interested in using Janus for one thing or another can get in touch and get our help to get this done, for instance. And that is, of course, a very important staple in our income, because, of course, working with open source, that's the obvious way to try and monetize a bit all this. Even though we also have a different column that we use, a different pillar in our income as well, which is we provide remote participation support to events as well. So we basically created a conferencing/webinar platform on top of Janus that we use for streaming some events. And this was we were doing this before the pandemic as well. So basically, for conferences that were interested in our services, we would fly to the venue, set up all the equipment, capture, place cameras, hook up to the room mixer and these sort of things, so that we could capture what was happening in the room, stream it via WebRTC to the remote participants, and still allow remote participants to chime in, to make questions or remote presentations and these sort of things. And one of the major clients that we have in that space was the IETF itself. So the entity that is standardizing the web protocols uses Meetecho for their own meetings that happen 3 times a year in different parts of the world. Of course, when the pandemic hit, they moved to a completely virtual approach, and that led us to basically refactor the platform to make it much more scalable and allow it to host thousands of participants all communicating together and engaging in conversations and working together as part of these conferences. And now we are going back to some sort of a hybrid event, because, for instance, I mentioned the meeting in Vienna last week, and that was indeed the very first hybrid event in the history of the IETF. So it was interesting and challenging for us at the same time, because, of course, we needed to make this work effectively with a lot of on-site participants and even more remote participants at the same time, allowing them to engage in conversations and work together without that much of a problem, providing solutions and technology to make it easy for them to interact with each other, for instance, shared queuing mechanisms for the mic line, these sort of things. And so while we do, of course, a lot of consulting, we are also focusing a lot on this other aspect, which is closer, let's say, to a product, if you will, even though it's very much a bespoke solution that we provide for different conferences like RIPE meetings or Afrinic and a few others. And the idea is to try and expand this a bit so that if there are other conferences that are interested in the same set of services, that's something that we can provide as well. Even though our main focus will always remain working and maintaining the Janus WebRTC server as an open source solution, and also making consulting and support over that as well.
Boy, there's so many questions backed up here, and we're almost out of time. But I'm sure I'd like to get in touch with you, frankly, to talk about events that where I work on. I mean, it's interesting because there are, like, the one that we have has been in the real world, and it went virtual, and now it's coming back to the real world. And we want to carry on the virtues of the other one, want to base it on open source. So without digressing too far into that, because we're running out of time, I need to close it to just 4 questions that we ask everybody. The first, if you could be brief about it, is there anything we haven't touched on yet that you'd like us to have touched on in the little time that we have left?
No, I mean, nothing specific, also because I realized that Janus is a general purpose component, so there is indeed a lot to talk about. So, I mean, there's people that are interested in very different things, and it's impossible to touch on all of those because it's used in gaming, and it's used in virtual reality, and it's used in telehealth and a lot of other things, and we just touched a few of those. So there could be a lot to talk about. So, for instance, I'm very passionate about music, and I'm starting to try and make WebRTC fit in there as well somehow. So there could be another hour or two just to talk about this as well. But as far as I'm concerned, I'm just happy to have the opportunity of discussing this in the first place and make more people aware of the work that we are doing. So nothing that comes to mind.
So I should say that the hook on the latest piece of music that you posted on Twitter, I thought would make a great hook for this show. so I encourage people to go to your Twitter stream and look at that and listen to what you've been producing. A quick three. First of all, do you have anything to say about blockchain? That's sort of a control question that we have. There are two more after that.
Not much. I mean, so far I've managed to stay pretty far away from blockchain, NFTs, and all. Yes. I mean, I try to stay away from that as much as possible, mostly because I don't know enough about it, and it's easy to have an opinion on that, especially in this time and age. So I haven't investigated much, and it's not a technology that I care particularly about.
I love that it's the less you know about something, the more you can have an opinion. Like there's this inverse relationship between knowledge and opinion.
I mean, yeah, that's true.
there's a verity in there somewhere. The last two are, what are your favorite text editor and scripting language?
The text editor that I use for my work in particular is called Genie, which is kind of it's not a complete IDE, it's not a complete coding environment, but it's much more than a generic text editor, let's say. So it sits right in the middle, and I always found it easy to use. And when it comes to terminal usage, I'm afraid that I'm one of those that use Nano, that prefer Nano and the simplicity of Nano over Vim as well, which is going to lose me a lot of friends. But I mean, I just like easy things. That's how I am. Easy to use.
I like liking easy things. Well, it has been great having you on the show. Everything's moving so fast in your category. There are a bunch of questions that went unasked that are just rich with possibility because the world's changing fast. So we will have to have you back. Stay tuned for that. And so thanks, Lorenzo. We'll see you soon, I hope.
Oh, thank you very much. It's been a pleasure.
So Jonathan, a lot there.
Fun stuff. I will say first off, no shame for Nano usage. That's the one that I tend to use too. So we have a soft audience here for that. Janus is a cool solution. It lets a lot of people do things that, like we talked about during the show, used to be extremely difficult to make work. You can get away from some of the big locked in platforms like Facebook and YouTube and all of that. You can host stuff yourself, but you can also, it's a niche solution so that you can do, IP security cameras over it. It's a neat toolkit for a certain set of problems. And I love the fact that they're doing everything out in the open and, made an open source project out of it. Whereas, they could have, kept that technology close to their chest. So, but it's out there. We can all use it and we can all work on it. And then some pretty exciting stuff for the future too, with WIP and all of that. I didn't get to ask him this, but I do have to wonder. There's that XKCD comic that talks about, oh no, there's 14 competing standards. Let's make a new one so that everybody uses. Oh no, there's 15 competing standards. I have to wonder if WIP is going to be another one of those. But it sounds like there's some very neat stuff going on behind the scenes, and it's always a bit reassuring to know that there are guys like Lorenzo on the IETF boards trying to bring some sanity to those different the different standards that body puts out. It's not just people from Facebook and just people from Cisco, but some open source guys there too.
Yeah, I mean, this is one of those areas where when you start hearing about it, you start digging into it, you realize how much is out there essentially in the public domain and how well the world can float on top of that, even as you have really you have the big companies doing things like, doing competing browsers that can screw over what the open source stuff is doing. But I would think they're getting better about that. I now have 8 browsers. Somebody we had on another podcast. No, it was this podcast. Yeah, last week with Avast. That's yet another browser. And but anyway, there's just so many variables going on. But if you have open source at the bottom as a base, those could be isolated at higher levels. So I want to get to the plugs, and I want to let you guys know that next week we have Marco Saric Saric, I'm not sure which, of Plausible Analytics. It looks to be a really interesting show. And so what's your plug? I know what it's going to be, but say it anyway.
I've got 2 things to plug. First off, if you're not on Club TWiT, you need to be, and go check out the Untitled Linux Show. We're trying to get our numbers up to be even more official, but we do have our own. We do have our own RSS feed. So if you want to listen to it, you've got to go to your Club TWiT page on the TWiT website and go to the members feeds, and the Untitled Linux Show is going to be one of those feeds that you can subscribe to. You can catch us live if you want to. We record Saturday afternoons. And then the other thing I plug is over at hackaday.com. I run the security column there. We go live with that every Friday morning, and that's where you can keep up with the security news from the week. And occasionally we break stuff there, but usually it's covering news that's already out there. But you get some interesting takes from me. Some of them good, some of them, well, I occasionally get brought to task by the readers, but that's all right. That's what the commenters are there for. But that's a lot of fun, and check that out.
I like the recursivity of how the title for the Untitled Linux Show is the Untitled Linux Show.
Yes.
It's
That is
known by what it isn't or something. So it's great too. I plug it as well. So thanks so much.
It's a placeholder that's stuck.
It's right. Exactly. All right, everybody. It's been a great one. We will see you next week. Marco Saric again of Plausible Analytics. This is Doc Searls and Jonathan Bennett, and this has been FLOSS Weekly. And I'll see you next week.
Hey, I'm Rod Pyle, editor of Ad Astra Magazine, and each week I'm joined by Tarek Malik, the editor-in-chief over at space.com, in our new This Week in Space podcast. Every Friday, Tarek and I take a deep dive into the stories that define the new space age. What's NASA up to? When will Americans once again set foot on the moon? And how about those samples from the Perseverance rover? When are those coming home? What the heck has Elon Musk done now? In addition to all the latest and greatest in space exploration, we'll take an occasional look at bits of spaceflight history that you probably never heard of, and all with an eye towards having a good time along the way. Check us out on your favorite podcatcher.